Editing using SmartTool language is based mostly on if, else if, and else conditions. And now we're going to go through what these conditions mean and how to use them and what tells them apart. First, you need to be aware of different parentheses that they are available. So when you're doing programming in SmartTool language, these normal parentheses are always after a condition. So the first part is something called if clause. The brackets are not used that much in SmartTool language, but of course there is a place for them as well. That's why they are a little bit more gray. But braces, so curly parentheses, are used a lot because that's the way to denote what SmartMed should calculate. In this example, if the condition is fulfilled, this would happen. So first we start if n we remember is total cloud cover, and then we are using the normal comparison signs. So here it says smaller or equal to 50. And if the condition is fulfilled, the edited temperature would be increased from the current value by 3 degrees. Remember, temperature is always in Celsius. And when we are talking about total cloud cover, it's always in percentages. And in SmartTool language, you can comment what you are doing by having 2 normal slashes. The text becomes green, which means that after that, after the 2 slashes, SmartMed is not taking those into calculation. You can also comment using your own language. So, if our total cloud cover is, for example, 65, nothing would happen because the condition is not fulfilled. The action inside the braces would only happen if the condition is fulfilled. And if our total cloud cover would be 65, it's not less than 50, which means that nothing would happen. But if our total cloud cover is, let's say, 10%, it is less than 50, and then the temperature would be increased by 3 degrees. Also note that 50 is now included to the condition. So, if total cloud cover is exactly 50%, the condition would still be fulfilled because this is smaller or equal to. We can add more conditions inside the if clause, and we can do that by using the word and. Now we have 2 conditions, and when we are combining these conditions with the word and, it means that both of the conditions need to be true in order for this inside the braces to happen. So in this example, if the total cloud cover is smaller or equal to 50, and the precipitation rate, so the precipitation intensity, is less than 0.05 millimeters per hour, the temperature would be increased by 3 degrees Celsius. So, if either one of these are not fulfilled, this action won't happen. If our total cloud cover is, let's say, 20% and our precipitation rate is 0.01, both of the conditions are fulfilled, which means that this will happen, so temperature would be increased by 3 degrees Celsius. But if our precipitation rate is exactly 0.05, both of the conditions are not fulfilled, because now that we don't have the equal sign here, it means that we are actually not including 0.05 number itself to our condition. So this won't be fulfilled. And with the word and, it means that both of them need to be fulfilled. This is mathematics, not meteorology. The reason I'm using 0.05 instead of just 0 is that usually very small amounts of precipitation does not matter. So it's small enough for me to think that that is no significant precipitation, and hence it's a good limit for my condition. But we can scale up. In SmartTool language, like in any other programming languages, you can have multiple conditions. So you can have if, else if, and else. If the first condition is not fulfilled, that is the if condition, it will take a look on the else if condition. And if that one is not fulfilled, it will finally take a look on the else condition. So first, we take a look that, okay, is our total cloud cover less or equal to 50%? If it's not, let's say it's 60%, it will go to else if. And then it takes a look on the else if condition. It says that total cloud cover should be over 50% and it should be less or equal to 70%. Our example of 60% total cloud cover would be within this range, so that would fulfill the condition, and hence this calculation takes place. So temperature would be increased everywhere by 2 degrees from the value that it is at the moment. Let's say our total cloud cover is 90%. First, the program takes looks on the if clause. No, it won't be fulfilled. 90 is way over 50. Also, the else if condition won't be fulfilled because 90 is over the largest value 70 that would be accepted to this range. So it has no other choice than go to the else condition that would take place in any other case except for the condition if or else if. With the total cloud cover of 90%, temperature would be increased by 0.5 degrees Celsius. Also note that the limit 50 should be included either one of these conditions. So I am including it to the first if clause by having the equal sign here, but I am not including it in the else if condition anymore because I have already included to the first one. So if you are having the same limit on multiple places, remember to include the exact limit value also on some of the conditions. Otherwise, the result might be surprising. For example, without the equal sign here, the value 50 wouldn't be included in either of these conditions, which means that if the total cloud cover is exactly 50, if condition won't be fulfilled. Also, else if condition won't be fulfilled because it's not included here. So with a limit of 50% of total cloud cover, actually the else clause would be fulfilled and the temperature would be only increased by 0.5 degrees Celsius, which is probably not what we wanted to have. So remember to include the limit value at least to some of your conditions. We already discussed that we also have some static variables that only have a value that you can refer to. And here is one example of those. There is a static variable called L-hour. L-hour is referring to your local time. So no matter where you are in the world, it's always your local time. So here, for example, L-hour is larger or equal to 19, which is 7 p.m. Or L-hour is smaller or equal to 6. It means that we want something to happen during nighttime. So from 7 p.m. until 6 a.m. And then during this time, we would like to increase the temperature by 3 degrees Celsius. But here the point is the word or that is dividing this condition into two parts. It's enough for this result to happen if one of these conditions is fulfilled. Note that actually word and wouldn't work in this case because mathematically it's impossible to have a value that is at the same time larger or equal to 19 and smaller or equal to 6. So this is really mathematics, it's not meteorology. If you want something to happen during nighttime and you want to refer to local hour, you have to have the word or instead of and. Here we have one example using another static variable, so topography. So here I want to increase wind speed by 10% if the topography is larger than 1000 meters. Topography is static variable that only has a value, and if the value is larger than 1000 meters, I will increase the wind speed, as it currently is, by 10%. And from mathematics, you remember that if you want to increase something by 10%, you have to multiply the value by 1.10. When working with if, else if, and else, it is very important to add the strictest condition first. Here we have an example. In the if clause, we are saying that total cloud cover being less or equal to 70, we will increase the temperature by 3 degrees Celsius. And then in the else if, we are saying that if the total cloud cover is less or equal to 50, we are increasing the temperature by 2 degrees. But in this case, let's say if the total cloud cover is 40%, we are actually fulfilling both of the conditions, because 40 is less or equal to 70. Also, 40 is less or equal to 50. So, in this case, the chosen value satisfies both conditions. However, if-else-if conditions stop running at the first satisfied condition. Here it means that as the first condition is satisfied, the latter will never run. To fix this, we should rearrange the conditions so that the strictest condition is checked first. So we would need to put the strictest first, 50 here, and then 70 here. Now it's the correct way around, and the strictest condition is first.